So now what we're going to do is we're going to keep working on this. We're going to do something in the loop, we're going to do something before and something after, and we're going to accomplish different things. So the first thing that we're going to accomplish is counting something, right? Counting the number of things that we are going to be looping through. Now in this case it's kind of silly, but just in general these are called counters. And so let's just say that we had, dot, 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 a whole bunch of these things, and we didn't exactly, we can look at this and say there are 6 of them, but that's not the point. The point is, if we have a loop, and in the loop we want to keep track of how many we've seen, well, you do this counting thing, okay? So the way it works is, you set a variable to 0, this is the top part. Normally this would be called count, but I'm going to use a bad non-mnemonic variable called zork, just so you don't get too used to it. So we so far, how many have we seen? Well, we've seen 0. And then we're going to go, thing is going to be 9, 41, 12. So thing is going to be the iteration variable. Each time through the loop, we're going to add 1 to zork. Increment is another word for this. Zork equals zork plus 1. We print out the thing we're looking at, and we print out the current value for zork. So the first time through 9, and then that's the first thing we saw. 41, the second. So, and each time this goes up by 1. It doesn't really matter what these things are, but then we run this many times, and when we're done, and we say, okay, loop is all done, right? There's the end of the block, and when it's all said and done, there were 6 things. Now again, 6 is kind of obvious. We could just look at it and know that there are 6, but this is a way to keep track of the number of times that a loop is executed. You set it to 0 at the place, you add 1 to it, and then you print it out at the end. At the beginning, before it starts, set it to 0, add 1 each time through, and then print out the count at the end. So that's counting. The next thing we're going to do is total up a series of values. So in this case, we're going to total them up. Makes a little more sense now. And we're going to have another variable, zork. I would probably call this total. During the loop, it'll be the running total. And at the end of the loop, it will be the total. And so total equals 0. Before, that's the running total of what we've seen. So now 9 comes out. And 0 plus 9 is 9, so the running total is 9, and 9 was what we looked at. Then 41 comes in, then we take 9 plus 41, the running total is 50, we read 41, go back up, 12 comes in, 50 plus 12 is 62, so that's our running total. Next time we get 3, 62 plus 3 is 65, so that's this line prints out. Then we get 74, so 65 plus 74, 65 plus 74 is 139. So that's the running total. We go and do the last one, 15. 139 plus 15 is 154. We print that out. And now it goes back up, but the for loop is done, so out we come. So at the end, when it's all said and done, this running total becomes the total, 154. So we certainly wouldn't print all this stuff out, right? You wouldn't print that out. But at the end, if you do this, and so the difference between the count and the total is instead of adding 1 here, you add the thing you're running that you're totaling up. So that's how we compute totals. And of course, we can do this with an average, right? So now we're going to have a counter, which we set to 0, a running total, which we set to 0 in the variable sum. We're going to print out 0, 0, so the count and the total is 0. We run through. Each time through, we add 1. So it's going to be 1, 2, 3, 4, 5, 6 each time through. Then we have the sum equals sum plus value, so 9, 50, 62, 65, 139, 54. So this is the running total. This is the count. Actually, that's the sum in this case, the sum variable. And then this is the thing that we were reading in. And then we finally get done, because there was only 6 things. The for loop dumps us out. And then we got, okay, how many did we get? We got 6. What was the total? It was 154. And then divide sum by count, and that should be 25.0. Okay, and so we divide sum by count, and now we have calculated the average. Actually, this should be 154 divided by 6. I think that should be 25.6666 or something like that. Okay, so you get the idea, and so you sum, and so you can do more than one of these things in a particular loop. Now, filtering is the idea that we're looking for something that meets some criterion. So we're going to go through and look at all the things in the loop, and we're trying to figure out if something is greater than 20, and we're going to declare that large number. So this is how you put an if in the loop. And so sometimes this loop will do nothing. Sometimes this loop will print out large number. And so value is going to be 9, and that's false, so it doesn't do anything. Value is 41, that's true, so it prints out this. Value is 12, so it does nothing. Value is 3, it does nothing. Value is 74, and so it prints this out. Value is 15, so that's false. It's done. Now the for loop knows, oh, we're done. Go on to the next line. Okay, so this is kind of a filtering pattern where, you know, we're going to do some if statement and conditionally run some code based on the value that we're looking at for now. So that's like searching for large numbers in our long list of numbers. Sometimes instead of printing something out in the middle of the loop, just like in functions, we don't often print in functions. We tend to prefer using return values. Sometimes we just want a variable that tells us whether something was found or not. And so we're going to use a Boolean variable. So a Boolean is another type of a variable. You got integer variables, you got string variables, you got floating point variables. Boolean is another kind of variable. Boolean is the kind of variable that it either has the value true or false. That's it. It can only have two. And so false is a constant in Python, and so I'm going to say found. Found is a mnemonic variable. I use the word found for this all the time, but don't get stuck on it. It just happens to be a variable with the value false. So we print it out before it's false. And now we're going to go through each of these values again, and we're looking for 3. And we want to know, did we find 3 or not? So we have 9, and it stays false. We have 41, it stays false. We have 12, it stays false. Now we have 3. This all of a sudden clicks to true. And so then we change the variable found, which is the same found here, to be true. So this time when we come up through 3, we run this code, then we print this, and it's true. Now it's 74, this is false, but we've changed the variable for found, so it doesn't change back to false. So we run the rest of the loop, and when we're done, true. And so at some level, if you didn't print all this stuff out, before, after, that means we found a 3. There could be 1,000,000 times that we ran this. And all we know when we're done is there was a 3 in there. So that's what's saying. Found starts out false, it loops and loops and loops and loops, and if it ever finds it, then found becomes true, and then we can detect at the bottom of the loop, yes, we found it. Yes, that happened. No matter how many numbers we looked at, one of them, at one point, at least one of them, was a 3. Now, if we were a little tricky, we would realize that we could put a break right here. Right there. Because once it's true, it's not going to go back to false, so we could stop. So we've done a bunch of different things, right? We found the largest, we searched for value, we did some sums, we did some averages, and now we're going to do the smallest value. And so just before we do the smallest value, let's review what we did for the largest value. Okay, and so we have this variable called largest so far that we set to -1, and then we print it out, it starts being -1. And then we're going to go through this loop, 9, and the largest so far is 9, and then we go 41, we like that one better, and then we like 12, we don't like that, we like 3, we don't like that, 74, we keep that, and then 15 doesn't make any difference, and then it pops out, and we get 74. That is the largest, not the largest so far, but the largest you would get. So the question is, what would we do to change this to make it search for the smallest value in the list? Now you can look. Humans are good at this. Like, hey, what's the smallest value? It's 3. Yeah, of course, you know that. Now, we got to think like a computer. How are we going to find the smallest value in the list? What would we change here? What are some of the things you might change? Well, there's at least a couple things you would change, right? So the first thing you would do is let's just change this from a greater than sign to a less than sign. And let's just change the word large to small. Is that going to fix it? Take a second. If I changed all the word largest to the word smallest, and I changed the greater than to a less than, is that going to fix it?